Hello, everyone, and welcome to Schmidtless Live. I am your host, Kurt Schmidt, president and partner at Foundry. And today's show is meant to inspire and educate leaders like yourself. So today we're going to be talking about all things AI, blockchain, and just all the buzzwords possible. And I've got my good friend BJ here to join me and help me wade through this sea of ever changing buzzwords. But before we get started, I do need to mention that we are hiring. Yes, we are hiring. What a shocker. What a surprise. Check it out, foundrymakes.com/careers. If you don't see a position there that exactly matches your description and you're an awesome person, well, send us a message anyways. We're also going to be releasing a new job posting soon for a director of finance. So check that out. If you know people, send them our way. We'd be more than happy to talk to you. So let's jump in here. We're going to be talking today about all the buzzwordy things. And thank gosh, I've got somebody who understands it way better than me. BJ. BJ, how are you today? Thank you for joining me.
Hey, Kurt. How you doing, man?
So tell me about what you do and where you're at. What are you doing these days?
Geez. It's been about a year and a half since we talked last time.
I know. Lots changed. Cool. Just a few things.
Yeah, just a few things, right? we don't have to talk about all that stuff. I'm sure everyone is tired of hearing that stuff.
Yeah.
I know I am. But let's see. I mean, things, we've been on the right side of all this stuff because like we were talking before, there's not quite a middle road here. There's not a plateau. You're on the right side or the wrong side of all the crazy changes that we've seen over the last year. Or more. We've been on the right side. We picked up a number of big Fortune clients and doing some really cool stuff in autonomous vehicles, autonomous robots, doing things in healthcare, revenue cycle, doing really cool stuff in a lot of biological systems modeling now, which is kind of a cool thing. Yeah. With a partnership with Mayo Clinic. And a number of other cool things through a company called Avance Health. So lots of really, really neat kind of opportunities that have popped up through all the cool things that you tend to come across. So lots of good stuff. But of course, through all of those things, are all of the buzzwords, right?
Yes.
Every time you talk to a new potential customer or client or partner or just about anything, I do a lot of phone calls with people just to talk, because that's a lot of this stuff really comes down to really just figuring out what other people are doing, right?
Well, I think the hardest thing with some of these buzzwords out there is a lot of the stuff is just marketing messages. It's not actual real information. And so, yeah, just like yourself, I have tons of conversations with people looking for some real answers versus a download the free ebook on how blockchain will change your business, right?
Yeah, or how it won't change your business because you probably shouldn't be using it.
Yeah, usually with those ebooks, I leave with more questions than I got answers to.
That is definitely true. Yeah. I've been doing as you know, but for those.
Tell me about Technicity and the work you do there.
At Technicity, we've been doing some really cool stuff. So we at Technicity, we kind of bill ourselves as a systems engineering firm, and what that means really is just about anything. And to be a little bit more specific, we really center around things like IoT, a buzzword, right? Internet of Things.
I love the IoT.
So,
the Internet of all the things.
Of all the things, right? And I really love Internet of Everything, IoE, right?
Ooh, that's a good one too.
And so a lot of this kind of stuff really comes down to, I've been morphing from saying IoT to connected systems, because you can really start putting things like a smartphone app. You can start even making an argument that that's IoT, right? If you have an app on a phone, that's IoT, especially if it ties into sensors on your phone, right? Which most apps do now, whether you like it to or not, from a location tracking perspective or motion tracking or whatever, right? So a lot of that stuff, goes all the way through. Technicity doesn't really do a lot of just plain old apps, although we've done a few social media stuff over the last year, in fact. But really, we focus on really that full stack systems engineering. And I hate, that's another buzzword, right? You hear full stack developer,
I get it.
Right? Back end, front end and stuff. That's not what we really do. We kind of do that on steroids, because that means everything from the bits and bytes and the circuit designs of those actual devices that you see, right? The circuit boards, layout, and all those different things connecting to real tangible things that move and light up and all that kind of stuff, all the way to the massive database scaling stuff. And all the way to the very top level of the cloud stack, right? And so that's really where we specialize, is kind of each piece of that. And my team is now 20 plus, all systems engineers. And one thing that makes us somewhat unique, I would think, is, and I haven't really run into this, is the fact that we don't actually hire software developers. Even though we are a lot of software.
Sure.
Mostly software, actually, because that's what connects systems.
Yeah.
We're actually a ton of engineers. And I always like to say it's a lot easier to teach an engineer how to code than it is to teach a software developer how to think in systems. And so not to offend anyone out there, the only reason I can say that is because I do have a degree in computer science. So I feel like I can at least, hate on myself.
Oh, sure. Yeah.
You're part of the club. I've actually added mechanical engineering to that, but I feel like I no one can really get me.
Right.
I mean, you can always hate me, but I feel at least a little justified being able to say that. Yeah. So anyways, that's what we kind of do. So we focus on all that kind of stuff.
Well, so that's back to the buzzwordy side of things, the Internet of Things. I think that also freaked out a lot of companies too, because you're going to put the internet in my tractor, and that's not what I want. I don't want people. Right. I don't want people from the internet having access to my tractor. So I think I get it. It's kind of this easy way to describe it, but like what you're talking about is a much more complex sort of premise of connecting all these different things. And when you connect them, it's not just about that they're tethered together. It's that the right hand knows what the left arm's doing, and they're talking to each other. They're passing information across. It's not just as simple as like, well, I can get, email on my coffee table now. Right.
Yeah. No, that's exactly. And I mean, even our last show, we talked about like, there's this idea of just because you can connect it doesn't mean you need to connect it. Right.
Right. Yeah. Just because you can doesn't mean you should.
Exactly. And that's monetizing that IoT is a really difficult thing. The reason that I got into IoT though, is because it truly is probably one of the most challenging things that you can do in computing. Mm-hmm. And the reason I say that, there's a lot of challenging things that we deal with on a daily basis, right? But IoT, I think, truly embodies complexity at its core. And the thing I love to do is make complex things simple, because that's what actually ends up winning every time, right?
Yep.
It's amazing. It's the simplest things that end up prevailing. It may take them a while, but it will always prevail.
Well, simple's harder than complex. It really is. But it's from a process standpoint, it's simpler. But from a human, we like to overcomplicate things. We're just kind of built that way. And so I think it's almost a cultural thing that you kind of have to get over to get to that simple idea. And I know I've seen that in large companies because you're exactly right, BJ. Like, this is a great time to be in IoT because there is so many systems out there that were never built to be connected to anything the way they are. And they're not really going anywhere because they are kind of like these monolithic structures that hold a lot of weight and a lot of data for things. And now we have to figure out channels in order to build into those things. So I can see exactly what you're saying, BJ. Like, it's a very exciting time because, but we can overcomplicate these things very quickly, which is why I really wanted to talk to you about things like AI and blockchain, right? Yeah. And because every single presentation I see, and let's just start with blockchain for a second. Every single presentation I see on the blockchain is that it's going to revolutionize connected systems. It's going to revolutionize the music industry. It's going to revolutionize the movie industry and the financial industry. And I'm still waiting for the revolution. Why have I not seen it yet? I mean, this technology exists. Why isn't my Apple Music on the blockchain right now?
Exactly. So before we can really answer that, I think we need to let's describe what blockchain is.
Yeah, let's do that, please. Thank you.
Let's embody this less is more concept, right? Let's just take it really simple. So really, when someone says blockchain, there's a lot of floating things around it. But when it comes right down to it, the way I look at blockchain is it's a decentralized database. So if you think about what a decentralized database means, right? What is a database? It's a place that you store a bunch of data.
Yep.
But right, and typically they're monolithic, right? They're either a software system that you shove a bunch of data in, and if you think about all this data, it's right next to each other, right?
Yeah, it's all in one space. I got it all there.
Yeah, exactly. So the idea of blockchain is to decentralize it. So what does that mean? Well, it means that everyone around stores part of the database. So it's just all this data is spread out. And how do you connect those things? Well, there's a lot of details in that, right? Cryptography, you connect them with hashing and all those different strategies. But and that's really where this this idea of a ledger comes into, and you'll hear about that. Blockchain is really good for financial systems. In fact, I've kind of said this before, and I'm waiting for someone to convince me differently. So I'm not sold on this concept, but I contend that the only place blockchain is really good for is cryptocurrency. And I mean, that's, and honestly, like if you take the whole less is more sort of mantra, the reason that it's really only successful, the only reason you see blockchain and why your Apple, iTunes aren't on the blockchain, right, but Bitcoin is, right?
Yep.
Ethereum is.
Yep.
That's why, because it really is a good way to be able to transactionalize, right? And the idea is behind this cryptocurrency is that you can really use this this ledger, this shared ledger, to privately and anonymously transact, right? Because they just look like hashes, which are just cryptographic sorts of strings that belongs to you, and can validate that it belongs to you if you keep your credentials, but no one else can necessarily see that, right? And there's lots of problems with that. So what are people talking about, right? Like what other things that are really popular with talking about blockchain? Well, supply chain, right? Supply chain, it's got the two, they share a word, chain, so obviously they should work together, right?
Sure, chain, well, yeah, right? Chain it all together.
Right, exactly. So manufacturing, right? So the idea that you have a very complex inventory management, and and none of the vendors trust each other, and those types of things. You can use, in theory, which is what everyone's trying to do, you can use blockchain to be able to verify the validity of the products and everything coming from multiple sources to then, centralize and unify a general strategy. Yep. Here's the problem with that, though. And this is why I contend blockchain is exceptionally difficult to implement, and why we probably won't see it unless everyone buys into it.
Okay.
And everyone's got to agree on this. So that's right there, right?
Right there is a problem. Yeah.
Really what it comes down to is that you have to buy into this idea of decentralization. And if you think about what decentralization is, it's directly competing with the concept of what business is. Because what business is about gaining a significant amount of resources together so that you can centrally control it in order to monetize it, right?
Right.
That is the goal of business, is to somehow centrally collect resources so that you can control and arguably transact better, right? I mean, that's capitalism at its core. In fact, if you go to the opposite side of the spectrum, right, it's the opposite side of the spectrum. Government, does that. Making no political statements here. I'm just saying, I get it. If you go to either end of the spectrum on control, it's either a company controls it, right, or the government controls it, right? So if that's the case, then who is actually going to buy into blockchain if they can't actually control something? And if you think about this, you can have multiple blockchains around, but then that's just more complex. Doesn't that kind of defeat the purpose of
one
Why not
just have multiple databases?
It's exactly like currency, right? Do you want to pay in Ethereum? Do you want to pay in Bitcoin? Do you want to pay in Dogecoin? All this kind of stuff. And there's
whatever Elon Musk tells me, BJ, that's what I pay him.
Okay, all right, there you go. But Bitcoin, let's do an ICO, Kurt. Let's see if we can get some value transaction.
I love it. NFT, man. Let's do it.
Yeah, let's do it. Yes, exactly.
Yes, actually, this show is going to be an NFT. I didn't tell you. I'm going to be auctioning off screenshots from this for $1 million a piece. Yeah, it's going to be really successful. I love it. So I'll give you 10%. Perfect. Well, yeah, and so that's the good point. Like you said, I think it really boils down to people agreeing this is the new standard, I guess, right? And and I can see where, and I joke about Elon Musk, but I mean, Tesla buying, a couple billion in Bitcoin is a pretty big deal to say this is a standard. Now, they're not the largest car company in the world, but they probably are the most profitable at this point. So, I think it does take these big sort of mountains to be moved to set a standard. But to your point, it isn't to put car data on the blockchain. It isn't to put traffic data on the blockchain. It's to get more Bitcoin. So
Yep, exactly. Well, and to play the financial markets, right?
Right.
It's an investment. It's an investment tool, and a smart one.
Yeah.
If you have enough, takes money to make money. If you have enough of a buying power, you can definitely shift that. So,
Right.
Yeah, a lot of the blockchain stuff, I just don't buy into. I think it's a beautiful technology. It's really awesome from a technology standpoint. A research perspective, I'm a principal investigator at Ohio State Center for Automotive Research. I work with large OEMs, specifically on blockchain projects. I've done some sponsored research on blockchain projects. I won't say who they are, but you could probably guess with 4 or 5 tries. Looking at data sharing, right? On cars and those types of things. This is no secret that everyone's considering this, right? If you have a number of vehicles on the road,
Right.
why don't you put them on a shared ledger, right?
Right. Yep.
You could do that, but then where's the control, right? There's safety considerations for that.
Yeah.
How do you do that efficiently when you really are dependent upon real-time transactions, particularly in an automotive sense, when it's very real-time focused in transportation and logistics? How do you transact on that blockchain and share the ledger in a real-time fashion?
Mm-hmm.
You need centralization. So why go through the complexity of the blockchain?
Makes sense.
There's all of those different things about that, and of course there's these crazy things that you'll see. So here's a transition for you.
Yeah.
Using ML, machine learning, and AI to help solve some of the problems of blockchain, of being able to do predictive analytics to push ledgers, across to be able to predict what the actual, how the ledger is going to evolve over time. And so you can do predictions and be able to do forecasting. It's a very, popular financial tool. So using things like AI to do that. So if you want to switch to talking about AI, which is actually the reason.
Well, no, and I love the buzzword stew we're creating here. We're just mixing it up. But that's the other thing about AI. So switching gears to AI, it's great. Everybody's worried that it's going to destroy the world or it's going to help the world. So back to the initial premise of setting a standard or agreeing on something. And the one thing I've always heard AI in blockchain is that, and I think you kind of alluded to it, is kind of removing the trust barrier, is that it's going to allow for more trust. The problem that I've seen in a lot of AI systems, though, is that the systems don't trust each other inherently in AI. So how do we overstep that? To back to your point, so I've got one machine learning, I've got this other machine learning, but then when they're talking to each other, they're like, I don't know who you are. I don't trust what's going on. So back to, even the beginning of our conversation, the connected systems, like this all feels like it starts to break down as it starts to get to a certain scale. Is that what you're seeing, or am I completely off base?
No, I think there's definitely a component of that, particularly scale. So let's set the stage on what AI, or at least how I view AI, right? And what is AI to me? So that, because AI means a lot of different things to a lot of different people. That's the problem with buzzwords, right? Everyone subscribes their own definition to it. So AI to me, artificial intelligence, doesn't actually exist yet.
Okay.
Because for me, AI is a very specific, realization that you need some sort of decision-making power that's exceptionally powerful. I prefer the word deep learning, which is a classification of neural networks and those types of systems. So let me take a step back.
Okay.
What is AI? What is machine learning, ML? Because they're not actually, they're the same thing, but they actually fall under a much larger classification of what I call optimization, which as engineers, we have done for years, just with dynamic systems and modeling and those types of things.
Oh, sure. Yeah.
We've done these things, right? Because what's a model? It's a prediction of real life. The thing about these ML and AI tools in the toolbox of optimization is that they're just data driven, which makes them actually pretty dangerous to the points that you were saying, really about explainability. So, instead of building a traditional model like we typically use on like using what I like to say, like a physics-based model, right? Where you can actually, build a mathematical model that represents the real life, like an electrical circuit or a thermal system or something like that. Instead, what we do is we take a mathematical structure and we feed it a bunch of data, and we train this structure that has no knowledge of the physics of how the world actually works. There's no tangible way that it knows. But if you feed it enough data, like we learn as humans, then it can predict just based on what it has seen in the past, right? And that's why we say we train these models.
Right.
And so you do that with machine learning algorithms like support vector machines and things like that, all the way to deep learning methodologies like neural networks and those types of things.
Right.
And so that is typically in the industry, everyone just says AI for that, right?
It's a big blanket statement.
And it's really that's a complete bastardization of the word AI. Artificial intelligence probably, it's just not there yet. And the reason is because of explainability. That's a huge research area. A research area that I'm involved in is the explainability of AI. So if you have enough data, and that's a big if, only some of that's a big if. We'll talk about that a little bit later, but remind me to talk about that. If you have enough data to actually train a model to then predict in most cases, you don't actually know, in many cases in the neural network, how or why it made that decision. Because it's basically just a bunch of statistics, a bunch of weights in this model that have been trained and been, calibration points that have been shifted up and down to then respond to an input set. And it just has an output, whatever that is. And so there's this idea, how do I explain the decision that was made? So let's say we feed a set of inputs. So let's say we're trying to predict traffic, right? Maybe we feed weather. Maybe we feed, a weather condition. We feed the time of day. We feed maybe even the amount of traffic that's on the road, for that day. And we're going to predict how long it's going to take me to travel somewhere, right? Maybe you feed your destination, right? Longitude and your starting point. So what that means is that if we use some sort of artificial intelligence for that model, you got these set of inputs we call features. We feed that in and we train it on a bunch of different observations of this. So we take a bunch of different routes of data that we've collected, hence why I like IoT. We can get to that amount of data. You can imagine you need a lot of data to be able to do this, right?
Yes.
And then we'll predict very simply one number, how long it's going to take me to get to where I need to go, right? Now, would I use AI for this example? Probably not. This is off the cuff, but
sure.
And what we'd actually end up doing with this is, if you think about it, how did you actually arrive at that? So let's say that I start to that answer of the amount of time that you travel. So let's say I start with a set of features. I start at my house and I want to go to work. Back when I went to work. And the idea there is being able to actually say, all right, what's the weather? Let's say it's raining. Let's say it's, 7 a.m. or whatever. And then it says it's going to take you 23 and a half minutes to get there. Okay, great. Why? Well, can you backtrack through? It's like, well, when I fed those inputs in, it went through this weight and this weight.
Sure. And
then it went through this weight. And then you got different layers of these weights. And it's kind of like, and then it just came up with this number, 23 and a half, this regression or whatever, 23 and a half minutes or whatever I said. And you kind of take a step back and be like, but what training data told you that was the answer? Can you imagine trying to save the amount of training data? You would have to know all the training that went into that in order to actually explain why it made it. Now, extrapolate that once further and say, what happens if I throw a crazy answer at it? Will it extrapolate? And it probably will, because it's just statistics. There's no boundary condition necessarily. And that's what we're all afraid of. And so being able to do input conditioning and output conditioning, these are terms and other buzzwords that you do to these models in order to bound them and put constraints on them so they don't go crazy on you. So AI, the explainability of AI is a huge, huge thing right now. And quite frankly, no one solved it yet. And so that's why we don't see that big thing. And that's, the adoption of these things in a huge way. You see articles, you see big news releases.
Yeah, well, it makes news.
PR, right? Yeah, it makes news. It's PR. But in the end, you know what ends up working and what we do most of, because we do a lot of AI and machine learning and stuff for large enterprises. We pick a very specific problem, very, very specific problem that is not mission critical, and we implement our data model for that. So maybe predicting when a bilge pump fails on your boat, or predicting, or predicting when a non-mission critical thing is going to occur. Later down the line, maybe for a warranty, so that you can do some modeling, financial modeling and things. Those are really good. But guess what? Those typically we end up using a rule base. So we write our own rules so that maybe we run that model in the middle, but we also pass it through that end rule base.
So you got to build guardrails.
Building those guardrails. So it goes to what you were saying before. Where are we at in that stage? That's kind of where we're at.
Makes sense. Yeah, so the question of the show was kind of like, what can AI and blockchain actually do for business? And what I'm hearing from you, and you can clear this up for me, but what I'm hearing from you is that the advice is first of all, start collecting data and make sure you've got data, because I know, and I've ran into this other businesses, is that there's tons of areas in their organization where they've never collected data before, and now they want to do, or at least I should say, explore these ideas of AI, blockchain, and machine learning, but the data just doesn't exist, and so you kind of got to start from scratch. And so a lot of the advice I've been giving business owners is just start collecting data. You might not know what you're going to do with it yet, but it's kind of like investing, right? It's like, let's invest in this data, because what I'm hearing from you say is that even though these things aren't figured out, these things are coming. They will have an impact in businesses, big and small, in the future. But for right now, probably the best advice is what I'm hearing from you is that start collecting that data now, because you don't know what you're going to be able to do. I mean, sounds like the sky's going to be the limit in the future.
It's true. I tend to have that same conversation with people. In fact, the most common conversation, as you said, is, hey, I've got this great idea to use AI. And my first question always is, do you have the data? And typically they say, well, I have some data. I say, how much data do you have? I've got I got 1,000 pictures and I want to be able to identify something. I was like, yeah, good luck. 1,000, it might sound like a lot to you. It's not. You need like a minimum of 50,000, to be able to do any of that kind of identification. All kind of depends, right? That's the other challenge with this. It all depends on what you're trying to do. But, it really makes sure that you have the data. That's number one. Okay. Number two, you can collect data. And I'm a big proponent of collecting as much data as you can. But when someone says, I do AI, like I do AI research or I do machine learning research, my first kind of, I would say ornery sort of kind of question to them is say, oh, so you spend about 90% of your time cleaning data. Right. And if they're honest, they'll say, yeah, you do that too, don't you? And I say, yes. And when it comes down to it, you can collect data. But if you're going to start collecting data, it is so critical to structure your data with features in mind. Before I was talking about, the feature set of, the weather and the location and the time of day. Those are features. So always, if you're going to be starting to collect data, which you should, it's always about that structure. And it's not as obvious as you might think. You're going to want someone to come in, like Technicity, little shout out here, to come in and say, all right, how do I structure this for machine learning? I don't know what I want to do yet for machine learning and AI, but how do I actually structure my data? Lay the foundation. Laying that foundation and defining those feature sets. And it's more complicated than just saying, what are the things I'm collecting? It's actually how you structure the data models. And so you can abstract into things like entity, values, and attribution, and those types of other buzzwords that you hear, EVA model, hierarchical data models, and those types of things. But do it in such a way that you don't lose performance when you're just trying to do the day old REST, representational state transfer, web service APIs, more buzzwords, and doing all of those technology things that, as a business analyst or someone as a VA, you probably run into on a daily basis. Your developers saying REST APIs and software SDK, software development kits, and those types of things. be able to still leverage that data in a performant way, but be able to then take advantage of it when in 2 years or a year or even 6 months, depending on the velocity of data you're getting, that you can start building those models. And that is so critical. And it is not obvious. And it is deceptive how it will creep up on you.
Yeah,
I've run into a number of organizations that came in, let's say 3 years ago, set them up on an IoT perspective. Or I went and talked to him and I proposed this and said, hey, just start collecting data, come and talk to me in some years. Or, maybe I can help you structure the data. They decided that it wasn't for them and they would do it themselves. They had a technology team. I said, great, go for it. Call them back in 2-3 years and say, hey, got that data now. Or they call me actually. Okay. And they say, hey, we got that data now. Can you come in? And I say, well, sure. Look, show me what you got. Without fail, the data said, yeah, we're going to need 6 months of cleaning, and I'm going to have to put an army of people on it because you're also going to need data labelers overseas to just go through and painstakingly, tediously click, that's a cat, that's a dog, those kinds of things in order to train, have humans actually train your data. And so that's why it's so critical to be able to have that attribution and those features kind of structured in your data models and accessible so that you can cut down on, frankly, the most expensive thing, and that is cleaning your data, because the training of the model is the quick part. And they say, oh, it's expensive. Your compute infrastructure, your Google Cloud Platform and ML managed services are going to be so expensive. Not compared to that army of people, the coders that you're having to hire that are having to write code to just clean the data that you thought was going to be ready for the taking for your new AI initiative in business, right?
Right. Well, and so let me ask you that last question here, BJ. So if, if it's not as simple as me just exporting a spreadsheet from my orders on my e-commerce site, what are some of those things I should be looking out for when I'm capturing that data? Is there particular ways, formats, different things that you would suggest looking at, and even storage for that stuff? I mean, what would your recommendations be as a business is going through that, trying to capture that information?
Right. So we'll get to some technical speak here potentially.
Sure.
So you've got you got your technology stacks, right? And so there's a lot of conversation about data modeling, and so I'll start there. From a data model perspective, you have to choose your technology appropriately, because it's how you actually store that data. So you meant your spreadsheets and everything. So you have a spreadsheet that's very relational in terms of their data, right? So you have these competing concepts of relational databases and NoSQL databases. Relational databases are like your Excel spreadsheet. You can list all the data out in rows and it's very clean and flat. A NoSQL database, on the other hand, is you can have all this nested data, in different forms. And it's powerful. Both of them are very powerful types of data modeling strategies and data technology decision strategies. But you have to be smart about which one you choose. And most systems that I end up proposing as well as implementing is a combination of both. Very rarely in today's day and age are you going to actually have one and only one system. Typically, your relational, like your spreadsheets, are going to be your system of record. That's the thing, that's the source of truth. Whereas you're going to have maybe some more of your higher velocity data, the data that's maybe a little bit deeper or needs to be accessed quickly, is going to be more NoSQL in technology stacks like Kafka and MongoDB and other types of Cassandra and other types of database technologies that I'm sure you hear about all day.
Yeah, sure.
Those types of things. So it's those types of those kind of data modeling strategies that you're going to need to consider, and you can't store them in an Excel spreadsheet. For the businesses that still think that they're going to be able to store all their stuff in an Access database or an Excel a whole bunch of Excel spreadsheets with macros, good luck, because you'll never get enough data to make it useful from a modeling standpoint.
That makes sense.
So a lot of those kind of technologies are pretty critical to consider, but it's also how you structure those things, right? And one last point on how you actually go and approach that structured data is really starting to look at the abstraction. So embrace abstraction. So I started today talking about less is more, and I may end in somewhat of a conflict from my messaging in terms of abstraction, because abstraction typically breeds complexity, right? But the idea is that a simple way to look at it is when you're designing your data, think of it in terms of categorization and categories. So if you have an account for a business, think about, instead of saying, okay, I'm going to write a table or I'm going to write a spreadsheet for an account, think about it in terms of an account type. So, abstract one level above that and say, okay, I have an actual type of account. It could be a business account. It could be a personal account. It could be those types of things. What that's going to allow you to do is be flexible on that kind of strategy. And then you could take that an even step further, right? A step further up and start talking about, well, can I just do an entity, right? Can I just represent everything as an entity? And the case is, yes, you actually can. And so structuring your data and thinking about that, because guess what that does? As you go down the path, and if you're abstracted enough, extracting those features in a clean way becomes very, very easy. And it allows you to do that discovery process to actually make your AI in the future actually work for you without the massive investment and massive time that it takes to actually get to a point to even see if it's going to work for you in your application. Whether that's predicting warranty claims, whether it's predicting, whether someone's going to do a click on that specific feature, all the way to those types of intangible to tangible things.
That's awesome, BJ. Well, I want to thank you so much for joining me today. If I want to know more about what the work you do over at Technicity, where's a good place to connect with you, BJ, and find out more? Because I can imagine people might walk away with even more questions from our conversation, which is totally positive they should, because it's not a quick conversation to have, right? So if I want to reach out and talk to you more about this, where should I go?
You can reach me at bj.yurkovich at technicity.io, technicity.io. You can find me on LinkedIn, maybe. I do not actually accept connection requests. A lot of people, like my list of connection requests is more. I don't actually accept them just as a matter of principle. I don't like social media. I don't do social media. Listen to my previous cybersecurity talk with you, Kurt, right?
Yep.
I know about that. But you can connect with me on there. You can message me,
Awesome.
Email me, find me on that kind of stuff. You can also find me in my research stuff. Look me up at Ohio State. The Ohio State University. I think the brand police will come and get me if I don't actually put the in front of it. Any of the other stuff. Mention Technicity. And if you're talking to a big enterprise, you might be surprised. Today, we do a significant amount of work with very large organizations. That's
awesome. Well, I know you're busy, and I really appreciate you taking the time today. And I'm excited to see more of the work you're doing.
Yeah. This is always a great to talk to you, Kurt. A lot of fun.
I appreciate it. All right, everyone, thank you so much for taking the time out of your day. I truly appreciate it. And I appreciate BJ and the work that they do over there. I always learn a lot from our conversations. I don't get to talk to them enough. So thank you for joining me and sitting in on that conversation. And before I go, I have to mention one more time, Foundry Makes. We're hiring people. Check it out. All right, everyone. Thanks. Have a great week, and we will see you next week with more live shows.